Math 76 lesson 38, adding and subtracting decimal numbers and whole numbers, and squares. So adding and subtracting decimal and whole numbers is a pretty simple task. They'll tell you to do something like this. They'll tell you to add, and honestly this probably could have been grouped into the previous lesson, but they like to make things in small bite-sized pieces to make sure you understand each concept before we move on. So we'll go ahead and go along with that. So if we have to add the whole number 12 and the decimal number 7 5/10, right? How are we going to do this? Because if you remember in the previous lesson I said the key to adding is make sure all the decimal points are lined up, but there's no decimal point in the number 12. So how in the world are we ever going to accomplish this? Well, we're just going to add a decimal point. Simple solution, right? It's not a huge problem. So we'll take the number 12, we'll go ahead and write that first, and then if we were to take the whole number 12 and turn it into a decimal, well then we would just put a decimal point and then add a 0 at the end, or a placeholder 0, as some of you may have learned it. And then I will add, now that I've got that decimal point and the 0 on the end, then I will add the 7 and the 5/10. From there, we just have a simple addition problem with decimals. 0/10 plus 5/10 is equal to 5/10. 7 and 2 is equal to 9, and then 10 and 0 is 10. So 19.5, or 19 and 5/10. That was easy. No way to stress out there. So it's really simple. If we ever have a whole number that needs to be added into a decimal number, we turn that whole number into a decimal number by simply adding 0.0 at the end, and 0/10. Okay. I'll do one more example. We'll go ahead and do a subtraction example. Let's say we've got, this will be a tough one. Let's say we've got 43 2/10 minus 5. Okay, so let's take 43 2/10, and then how in the world am I ever going to turn 5 into a decimal? Well, I will just add and 0/10, decimal point 0. So let's go ahead and subtract. 2/10 minus 0/10 is 2/10. 3 minus 5 doesn't work, so I have to regroup this 10. That 40 becomes a 30. That 10 becomes 10 ones. 13 plus, how did I switch operations? 13 minus 5 gives me 8. And then I don't forget to bring down my decimal point. And then 30 minus nothing is 30. So 38 2/10. That is my final answer there. Now, let's talk about squares. Quick thing about squares, I'm pretty sure I've mentioned this before, is squares are like perfect rectangles in that, well, let's go to a different color. We're changing topics, changing colors. Squares are like rectangles that are perfect because all the sides are the exact same length. For example, if I have a square right here and each side is 3 feet, or well, if one side is 3 feet, then all the other sides have to be 3 feet. So 3 feet. 3 feet, 3 feet, 3 feet, 3 feet. Okay, cool. So how do I find the perimeter of the square? Well, I'm just going to take 3 plus 3 plus 3 plus 3, or as some of you may have realized, the faster way of addition is to multiply. So since I have 3 being added 4 times, I could just take 3 times 4. So our two options to find the perimeter are, we'll do perimeter in purple. All right, so perimeter can either equal 3 plus 3, plus 3 plus 3, or it could just simply be 3 times 4. And both of those are going to give us 12 feet, right? And then if we need to find the area, all we have to do is take 3 times 3. So the area of a square is going to be the side times the side, or 3 times 3, which will give us 9 feet squared, or we could say 9 square feet. Okay. Now, the reason why I go over this again, some of you are thinking like, Mr. Claiborne, we already know this, you taught us this, is because we're going to start getting two-step problems with squares. One, for example, right here, whoops, no, right at the bottom of the page, hard to focus on, hard to get to. Let's see here. Here we go. They tell us that the perimeter of a square is 12 inches. What's the area? Well, if my perimeter is 12 inches, and I know I can find the perimeter by multiplying the side by 4, then I can do the opposite action to find the length of one side. So in order to find the area of the square, I need to know how big one side of the square is. So if they tell me that the perimeter is equal to 12 inches, to find one side, that is going to equal the perimeter divided by 4. So 12 divided by 4 is equal to 3 inches. Okay, so one side is equal to 3 inches. Is that my final answer? No, because if you remember, the problem wanted to know what's the area of the square. So now that I know the side, all I have to do to find the area is multiply 3 inches by 3 inches, which gives me 9 inches squared, or 9 square inches. So the area is 9 inches squared, and that is my final answer. And let's do the opposite. Let's say they tell us that the area of a square is 16 inches. Or no, let's go centimeters. We did feet, we did inches, let's do centimeters. Let's say they tell us the area is equal to 16 square centimeters, or centimeters squared. How can I find the perimeter of the square? Well, I have to know my square roots, right? So essentially what I have to do here is I have to figure out what number times itself is going to equal 16, right? So I can figure out the side, because the side is just going to be the same number times itself. So think about your times tables. Do you know any numbers times themselves that equal 16? 4, right? Hopefully we all came to that on our own. So I know that 4 times 4 equals 16. So the side of each side of the square must be equal to 4. So if a side is equal to 4, then the perimeter must be equal to the side added up 4 times. So the perimeter is going to be equal to 4 plus 4 plus 4 plus 4. Or if you remember, the fast form of addition is multiplication, so I'll just take 4 times 4 times, and I will get 16 both ways. So that will be 16 centimeters. And notice these centimeters are not squared the same way that the area was. So a funny thing with squares, every now and again you'll find out that the perimeter is equal to the area. Odd. Okay. That's it. That's all there is for this lesson. If you have any questions, let me know on the school website, and I will see you in class.